So in this lesson, we're going to talk about inverse trig functions. So for a function to have an inverse function, it has to be one-to-one. That means that it has to pass the horizontal line test. So sine looks like this, right? And it doesn't pass a horizontal line test, but it would if we restricted its domain to go from like here to here, right? And we just did one little section, all right? Arc sine of x is the same thing as sine to the inverse right there of x. So this means sine inverse of x. This is the same thing. So they can be written either way, and it has the same definition. So the definition of an inverse sine function is defined by y equals arc sine x if and only if sine of y is equal to x, where x is between -1 and +1, and y is in between -pi/2 and +pi/2. So the domain of y equals arc sine x is -1, 1, and the range is -pi/2, +pi/2, which is exactly stating this, but in interval notation. All right, so if we're looking at a graph, right, if I were to go from -pi/2 to +pi/2, that would be the first quadrant, and then the first quadrant that's backwards, right? So these would be all the negative values of these. So this is -pi/6, this would be -pi/4, -pi/3, -pi/2. So we're going to use that to help us with some of these. So what this means is you're kind of working backwards. Instead of going to the angle and finding the sine or the cosine or the tangent, you're finding the angle. So you should think to yourself, what angle has a sine of, and then insert this number right here. So this is what angle has a sine of -1/2. Well, remember, when you're doing sine, you're looking in the first quadrant and the fourth quadrant because this is the backwards, right? So if you look at these, the sine values are all the y's. Well, this is not -1/2. This is not -1/2. This is not -1/2. So the angle that has a sine value of -1/2 is -pi/6. Nope. Might help if I go to the right thing. So -pi/6. So remember, all of your answers should be between -pi/2 and +pi/2. All of these numbers should be between -1 and +1. So if you get one that's not, then you've got a problem, right? So check to make sure that what you're looking at right here is between -1 and +1. It is. And then you're going to say, what angle has a sine of 0? So I look at my unit circle. I look for the y values. So from here all the way to the bottom, the one that has a sine value of 0 would be 0. Don't pick 2 pi because that's not in between -pi/2 and +pi/2. So we've got 0. All right. Now, if you don't know what's listed right here, if that's between -1 and 1, then just plug it into the calculator and see what it is as a decimal. All right, then you would know. So you're looking for an angle that has the sine value of √3/2. So √3/2, y value right there, pi/3. All right, √2/2, that is between -1 and 1. So what angle has a sine value of √2/2? I look right there, y value of √2/2, that gives me pi/4. And then if you look, what you're trying to figure out is an angle that has a sine value of 2, but that's not between negative 1 and 1, right? So this answer, you don't have an angle, so we'll just say not applicable. So for your inverse cosine function, your x values, or the number that's right here, need to be between negative 1 and 1. But this time your outcomes, or the angles that you're going to get as answers, should be between 0 and pi. So any angle that we get should be between 0 and pi. So any of these angles right here between 0 and pi. So you're saying, what angle has a cosine of square root of 2 over 2? So if you look at your unit circle, that's the x values, right? So I find an x value of square root of 2 over 2. That angle is pi over 4. All right, and remember, you want to make sure that that number that you're taking, the cosine, finding the cosine of the angle that has that angle, is in between negative 1 and 1. So this is in between negative 1 and 1 because we do have the equal to bar, so we know that it can be equal to negative 1 as well. So what angle has a cosine value of negative 1? So I find the between here and here. Here's the x value of negative 1, so that would be pi. All right, and what angle has a cosine of 1? So I look for an x value of 1. That's right here at 0. All right, for tangent, the number that you're trying to find, what angle has a tangent of that number, it can be any number. It doesn't matter. So you don't have any restrictions on the number that is in this spot right here. But your outcomes should be between negative pi over 2 and positive pi over 2, just like with the sine. The only difference is, do you notice that these don't have the equal to bars? And if you look at sine, sine had the equal to bars, right? So you can pick any number in between, but you could not have a value that is at negative pi over 2 and at pi over 2. All right? So I'm going to find an angle that has a tangent of 0. Now remember, to find 0, you take the y value and you divide that by the x value. So it's not just a number that's on the ordered pair. You have to do a little bit of work. So I'm going to look here. So if I took the y and divided it by x, that would have to be right here, correct? So 0 divided by 1, and so that is the angle 0. All right, what angle has a tangent value of negative 1? Well, that means I would have to have opposite signs for these, right, because it comes out to be negative, and I'm dividing them. And they have to be the same number to come out to be 1. So if I look at the bottom, I've got negative square root of 2 over 2 divided by the negative, or the positive square root of 2 over 2 comes out to be negative 1. So that would be the angle negative pi over 4. Don't pick 7 pi over 4 because that's not between pi over 2 and negative pi over 2, right? You need a coterminal angle there. So that would be negative pi over 4. All right, so what angle has a tangent value of the square root of 3? Well, I know it's positive, so it's going to be one of these, because if I divide any of these down here, they come out to be negative. And then already on my unit circle, the one that I have handwritten down, I already put the tangents out here, so it's helpful sometimes to go ahead and list what your tangents are. So for instance, I might say, okay, well, if I took 1/2 and I divided that by square root of 3 over 2, that would be multiplying by 2 over the square root of 3, right? Which would give me 1 over the square root of 3, which simplifies to square root of 3 over 3. This is 1. And then this one would just be the square root of 3. So if you have those written down, then you don't have to constantly keep dividing the y by the x. So this would be a tangent value of square root of 3 over 3. I'm looking for a tangent value of square root of 3, which would be the pi over 3. And then I'm looking for a tangent value of a negative square root of 3 over 3. So if it's negative, I know it's going to have to be one of the negative angles down there in the fourth quadrant. So if you look at these, this is the square root of 3, so this will be the negative square root of 3 over 3. This is positive 1, so the middle one will be negative 1. And then your one closest to the vertical here is square root of 3, so this will be negative square root of 3. I am looking for negative square root of 3 over 3, so that would be negative pi over 6. So if you take the tan of the arctan, and those are the same, they just cancel, and your answer is negative 5. So same thing with this. If I take the arcsine of sine, I just get 5 pi over 3. Okay, we messed up on this one just a little bit, though, because your outcome can't be 5 pi over 3, right? So 5 pi over 3 is all the way around into the fourth quadrant this direction, which is too big, right? So it has to be a number that's either in first quadrant or backwards 1, right? So it has to be between pi over 2 and the negative pi over 2. Well, this is in that quadrant, but it's one round too big, right? So we need to take away 2 pi from that to give us a coterminal angle that's in our range. So subtract 2 pi. So if I take away 2 pi from that, that gets me negative pi over 3. And now that is within my range. So just be careful there. Remember, for tangent, it doesn't matter. It can be anything. Now, these get a little bit different because I'm taking the tangent of something else, right? And they're not inverses. So what you're going to do is you're going to do this part first. So remember, this number right here has to be in between negative 1 and positive 1, right? And I know that because if you reference this back here, I know that that number has to be between negative 1 and positive 1, all right? So first you want to check that just to make sure. Now, you're looking for an angle that has a cosine value of 2/3, but that's not on your unit circle, right? So you're going to draw yourself a triangle. So this represents the angle that you're trying to figure out. And I know that that angle has a value of 2/3 for its cosine. Well, cosine is adjacent over hypotenuse, right? So that means that 2 would represent the adjacent side. That would be this side. So 2. And hypotenuse would be 3. All right? So I've created a triangle based off of this part right here. So now I'm using the same triangle. I want to find the tangent value. Well, to find tangent, I need the opposite side over the adjacent. So I need to find the missing side. So this is a leg. So I'm going to do the square root of the hypotenuse squared minus the leg that I have squared. So 9 minus 4, which is 5, correct? So I get the square root of 5. So to find the tangent of that same angle, I do opposite over adjacent. So that would be square root of 5 over 2. So if we look at this one, we're going to do this part first. We're going to make a triangle on that. Again, make sure that this number right here is between -1 and 1. It is. So the negative, that should go up here because sine is opposite over hypotenuse, and the hypotenuse is never negative, right? So I'm going to draw myself a triangle. Put my angle there. So in reference to this angle, the opposite side would be -3, and the hypotenuse would be 5. All right? And tell you what, we might want to draw this in the correct quadrant. That way it's shaped correctly. So think about your quadrants here. Remember, sine, that is either going to be up here or down here, correct? So if it's negative, that means it's going to have to be down here. We'll do this that way we can make sure that we have the right numbers. So we have -3, and then your hypotenuse is 5. And if you know your Pythagorean triples, you know that the other leg is 4. If you don't, then you can do the square root of hypotenuse squared minus the leg that you have squared. Make sure you square that in parentheses. So you get 25 minus 9, which is 16, right? And the square root of 16 is 4. And I know that it's positive because it's coming out in a positive direction. So then I would find the cosine of that same angle. Cosine is adjacent over hypotenuse, so that would be 4 over 5. All right, so we're going to start with this one in here. First, make sure, since we're doing sine, this needs to be between -1 and 1, and it is. So I know that sine is either going to extend into the first quadrant or the backwards first quadrant, right, which would be the fourth. Since it's positive, it will be in the first quadrant. So put your angle right there. And I know that sine is opposite over hypotenuse. So I've got 4, and then hypotenuse is 5. And if you know your Pythagorean triples, you know that this side is 3. If you do not know that, then you would take your hypotenuse minus the leg that you had squared. So 25 minus 16, which is 9, and the square root of 9 is 3. Then you find the secant. Well, remember, secant is the opposite of cosine, right? Well, cosine would be the adjacent side over the hypotenuse, so that would be 3/5. But you're going to flip it and make it 5/3. All right, so same thing. We're going to start with this one. First off, let's make sure the square root of 5 over 5 is in our domain there. So if we take the square root of 5 and we divide that by 5, I'm going to push that little button to make sure to change it to decimal. That's definitely between -1 and +1. So we're good there. So if you don't know, plug it in. All right, so cosine, that's either in this quadrant or this quadrant, correct? If it's positive, it will be in this quadrant because that's my x value, and that's a positive direction for x. And I know that this is adjacent, so square root of 5 over hypotenuse, which is 5. And then I need to find this other leg so that I can find the sine. So I've got the square root of my hypotenuse squared minus the leg that I have squared. So square root of 5 squared. All right. And sometimes you can plug this in and it is fine. It'll give it to you. Let's see if this will. So we have square root of 5 squared minus the square root of 5 squared. And it tells us that's 2 square roots of 5. If you have trouble with it giving that to you, then simplify underneath. Say that's 25 minus 5, right? And then plug it in and it should give it to you. So 2 square roots of 5 is this side. And I know that sine of that same angle would be the opposite over the hypotenuse. So that would be 2 square roots of 5 over 5. I would make sure that I can't reduce. I cannot. And so I'm done. All right, so first let's take care of this. So I know that tangent is going to either be in the first quadrant or this fourth quadrant. All right, since it's negative, it's going to be this fourth quadrant. Put our theta right there. And so I've got arctangent is -5 and then +12. So you need to think about where this negative is supposed to go. I know that tangent is opposite over adjacent, right? And I also know that it's in this quadrant, correct? Also, tangent is sine over cosine, which is y over x, right? Well, if you think about where this angle is located, you go in a positive direction for x, and then the y is the one that goes down. So this negative needs to go with the 5. So opposite is -5, and adjacent is 12. So you're going to have to give that a little bit of thought for the tangent because it's an x and a y, right? So decide which quadrant you should be in. I know it's not this one because everything's positive there, right? I won't have anything negative. And then think, okay, it's opposite over adjacent, so the y is the one that is negative because it's going down. All right, and if you know your Pythagorean triples, this is 13. But if you're going to find that, if you can't remember, you will do each of your legs squared and added together. So I've got -5 squared plus 12 squared, which is going to get you 13 for your hypotenuse. All right. So then I'm finding cosecant. Remember, cosecant is the inverse of sine. So find sine. Sine is opposite over hypotenuse. So that would be -5 over 13. But since we're doing cosecant, we need to flip it. So it would be -13/5. And then the bottom one, so sine, we're definitely between -1 and 1. Sine is either going to be in the first quadrant or this fourth quadrant. It's negative, so I know it's going to be the fourth quadrant. And I know that this is going to go on top because my hypotenuse is never negative. So I've got opposite would be -3, and the hypotenuse is 4. And you want to say that this is 5, but you can't because that would mean that a leg was bigger than your hypotenuse, and that can't happen. So we're going to have to do our distance formula, not distance formula, our Pythagorean theorem thing. So I've got my hypotenuse squared minus the leg that I have squared. That would give me 16 minus 9, which would be 7. So square root of 7. And I know that then if I take the tangent of that, opposite over adjacent, but we don't leave roots in the bottom, so I'll either plug that in or I'll just do it by hand and rationalize. So that gives me -3 square roots of 7 over